So here we go, Chapter 7, Section 3. We're going to talk about power functions and function operations. We're first going to start talking about function operations. What is a function? Remember, a function is just an equation, an expression. We're going to talk about the function f and the function g, and we're going to be doing things with it. And when we do these operations, we're going to be creating a new function. So addition. So before we continue, I want to talk that we have some guests in the audience today. We have Jessa, Riley, and Drew. Say hi.
Hi.
If you hear other weird things like that in the background, I apologize. I will keep them, they're talking to a minimum as we go through the rest of these notes. So we want to talk about how to find my new function. My new function we're going to call h of x. Can I use any variable to talk about it? Yes. And just like this said, I want h of x to equal f of x plus g of x. Well, what's f of x? F of x is 2x. What's g of x? Well, that's x plus 1. So 2x plus x plus 1 is going to be 3x plus 1. So my new function h of x is 3x plus 1. That's addition. Well, how does subtraction work? Again, I'm going to have a new function h of x, which is f of x minus g of x. So h of x is going to be 2x minus, don't forget the parenthesis, x plus 1. Yes, Mr. Lovell, I'm talking about you. Don't forget the parenthesis. At this point, I have to distribute that negative through, and I get 2x minus 1. So my new function h of x is x minus 1. So let's try multiplication. Again, let's do this. I want to create a new function. My new function is going to be h of x. I want to multiply these two. And so when I multiply, h of x is now going to be 2x times, let me pick a different marker for that, excuse me. H of x is now going to be 2x times x plus 1. I have to distribute that 2x in. So my h of x is going to be 2x squared plus 2x. That's multiplication. Lastly, my new function is h of x, and now I want to divide. And when I divide h of x, I am now going to get 2x divided by x plus 1. Since this is addition on the bottom, I can't break anything up, and that's going to be my final answer. These are the operations, the function operations. I can add, I can subtract, I can multiply, and I can divide. Now let's talk about doing these operations with powers. So next slide. Example 1, let f of x be 2x to the 1/2 and g of x be negative 6x to the 1/2. I want to find the sum of these. So, well, again, my new function h of x is going to be 2x to the 1/2 plus negative 6x to the 1/2. Well, look at this. My power, my exponents are the same. My variables are the same. So this is telling me to say 2x to the 1/2 minus 6x to the 1/2. Since the variable and the exponents are the same, I just subtract. 2 minus 6 is going to be negative 4x to the 1/2 power. That is my answer. So now this is asking me to find the difference. Again, my new function h of x is going to be the difference of these two functions. So this is going to be, I didn't write this above earlier, I'm sorry. This should be f of x minus g of x. Up here, I should have had my h of x is equal to f of x plus g of x. That's what I did, but I actually didn't write that one step out. So what does this look like when I work out this problem? Well, I know what my new function is going to look like. I'm now going to plug in my f of x and plug in my g of x. So this is going to be 2x to the 1/2 minus a negative 6x to the 1/2. Once again, My exponents are the same. My variables are the same. So this is 2x to the 1/2 plus, because minus a negative, plus 6x to the 1/2. Since my variables and exponents are the same, I can just add and get 8x to the 1/2. There's my answer. There's adding and subtracting, or sum and difference, of functions. I just plug in the function and I solve for it. Well, what else can I do? Well, as I did earlier, I can multiply and divide. So again, my new function h of x is going to be f of x times g of x. So I'm going to plug in my f and my g. So f of x is 3x. G of x is x to the 1/4. Now I want to multiply. And remember, when I multiply when I multiply and my bases are the same, I add the exponent. So this is 3x to the, well, x to the 1, this is 4/4 times x to the 1/4. So this is 3x to the 5/4 power. That's multiplying my functions. So now that I've done a product of my power functions, let's do a quotient of power functions. Quotient again means to divide. My two functions are still the same. My new function, of course, is going to be, as I called it, h of x. Could I call it I of x, m of x, k of x? I can choose any name for the function. Here I'm choosing h. So h of x is equal to f of x divided by g of x. Well, where f of x is 3x, g of x is x to the 1/4 power. Remember the way this works. When my bases are the same, x and x, I want to subtract my exponents. So this is 3 times x to the 1 minus 1/4. Common denominator is 4, so that 1/4 is actually 3x to the 4/4 minus 1/4. 4/4 minus 1/4 is 3/4, so this is x to the 3/4. That's my final answer when I subtract my exponents. So I've added my functions, I've subtracted my functions, I've multiplied and divided my functions. And all my functions have been powers. I had exponents that were powers. What do I do next? Well, there's something else that I can do, and that's called composition. A fifth operation that can be performed with two functions is the composition of those two functions. The composition of two functions can be written two different ways. This is f of g of x, and this is also read as f of g of x. I can write them both the same way, both ways, but it's saying the same thing. This means that the function g will be substituted into the function f. If you are given g of f of x or g of f of x, then this means the function f will be substituted into the function of g. What in the world am I talking about? Let me see what I can help you with. So one more time, how do I use this in actual problems? Let's do some examples. Example 3. Let f of x equals 3x to the negative 1, g of x equals 2x to the negative 1. Find the following, f of g of x. In my opinion, in showing this, this is the best thing that I can do when it comes to how I want to do this. I want to take the function f, and I want to evaluate g of x inside the function f. So what I'm going to do is I'm going to leave the function f alone. What's g of x? Oh, well, that's 2x minus 1. Well, great. That is in place of, well, what do I usually write there? I usually write f of x, right? So in f of x, everywhere I see the letter x, what do I need to put in its place? 2x minus 1. So that means my function is now, put down the eraser, my function is now 3. There's an x. What do I write in its place? 2x minus 1. Finish off f of x and put it to the negative 1 power. All right, so at this point, I need to work this problem. But you need to make sure where this problem came from. Whenever I see a G, whenever I see an X, I need to plug something into that X. So G of X we knew was 2X minus 1. So I plugged it in to F of X. So F of 2X minus 1, wherever I see an X, I had to plug in 2X minus 1. So this is the problem I need to now evaluate. So what does this look like? This is 3. Well, this negative 1 tells me to take everything that's in the parenthesis and put it in my denominator. So my function f of g of x is equal to 3 divided by 2x minus 1. That's my final answer. I evaluated it as much as I could, so I stopped there. Let's try B. One more time. B says f of g of f of x. So I want to start on the inside. What's f of x? I start by writing g of, well, my f of x is 3x to the negative 1 power. Well, what's my g? Well, my g is now 2 of, well, what do I plug in for the x in my g? I'm going to plug in 3x to the negative 1. And then I need to finish off my g and write minus 1. How does this work now? Well, let's see. 2 times 3 is 6. X to the negative 1 goes into my denominator, so that's 6 over x, and then I have a minus 1 on the end. So g of, let me pick a different color, g of f of x is equal to 6 over x minus 1. I take whatever is in the parentheses and I plug it into the variable x in the problem. Letter C, I want to do f of x. So this is telling me I want my first f of, well, what's f of x? F of x is 3x to the negative 1 power. Well, now what do I want to do? Well, wherever I see an x in f of x, I need to plug in 3x to the negative 1. So I'm going to start by writing 3. Then I have what's in my parentheses, 3x to the negative 1. Now that needs to be the negative 1 power. I'm now going to distribute that negative 1 through. That's a mistake, excuse me. Get rid of the blue. Don't know where the A came from. Distribute into the parenthesis only. So the 3 in front stays there. The 3 in front stays there. This is times 3 to the negative 1. X to the power to a power positive 1. So this is 3 over 3x, which is 1x, or x. So f of x is x. Let's do a couple more. So now I have two other functions. I have f of x is equals x to the negative 1. G of x is equal to x plus 1. I want to start with my f. So I write f of, what is g of x? G of x is x plus 1. Everywhere I see an x in f of x, I now need to plug in x plus 1. So I'm going to start writing my f of x. Well, the first thing I see is an x, so I'm going to say, oh, that's x plus 1, and I'm going to finish writing f now, so that's to the negative 1 power. Now I'm going to work it out. The negative 1 tells me to put it in my denominator, so that's 1 over x plus 1. So my function f of g of x is 1 over x plus 1. Letter B, I want g of f of x. You start by writing the letter g of, then I need to write whatever f of x is. F of x is x to the negative 1 power. Well, now I need to plug in, wherever I see an x in g of x, I need to plug in x to the negative 1. So first thing I see is an x. So I say x to the negative 1, then finish off g by saying plus 1. So this is going to be 1 over x plus 1. I'm done. So again, g of f of x is equal to 1 over x plus 1. Last problem, f of x. I'm going to say, well, I want f of, what's my f of x? X to the negative 1. Okay. Wherever I see an x, I have to plug in x to the negative 1. So I'm going to say x to the negative 1. I just plugged in, ignore that bell, negative 1. Power to a power, negative 1 times negative 1 is 1. So this is just x. So f of x, again, is x. Now, is f of x always going to be x? No. And these two examples, did it turn out to be that? Yes. But it won't always be that way. We'll do more of these in class, and we'll see how things go. Talk to you later. Say bye, Drew. Bye. He meant to say bye, Drew, but